This is an example of a definite integral problem. You know it's a definite integral when your integral symbol has numbers for its bounds. So we're looking at the definite integral from 3 to 7 of the sine of x dx. So the integral symbol up in front and the dx at the back are just directions telling you what to do to this sine function in the middle here. All of your trig functions, sine, cosine, tangent, all of those ones that you had to memorize their derivatives for to find them, guess what? You've got to memorize them going the other direction as well. And so this is just what I refer to as a special case derivative or antiderivative. You have to have these memorized. There's no way of really getting back to them unless you do. So when we do this one, the special case for sine, so if I have the sine of a number times x on the inside, memorizing it with this version here where we add the number in is going to save you a lot when it gets into more complicated trig functions. So coming out of here, we will get negative 1 over whatever that value is, that a value, and then sine came from cosine. That negative is from the fact that when we took the derivative of cosine, we should have gotten negative sine. And then when we're doing it as a special case, when it's written as an indefinite integral, I always put it plus c at the end. So when we come to use this special case in our scenario here, really what we have going on for our a value is we've got an unwritten 1 right there. And so really we don't need to write negative 1 over 1 because that would just be negative 1. So we would write this as, I'll put it as negative 1, and then sine comes from cosine, and then that would stay the same inside there. When you are evaluating a definite integral, you get this little evaluation bar at the end. So you would say evaluated from x equals 3 to x equals 7. To do this, I just apply what I call the top minus bottom game. And so what you're going to do here is you're going to take the top value, plug it into that equation, and you'll subtract off the bottom value plugged into that equation. So for us, we're going to get negative cosine, and then plugging in for the top value, I would plug in 7. So that's our top value. Subtract from that the bottom value plugged in. So the negative cosine, and then the bottom value was 3. From there, you're just going to plug those into your calculator. There's nothing crazy about those. You're not going to get those off of a unit circle. You definitely just need a calculator. Pop them in, get out your value, and out of there you would get out negative 1.743. And so that is the net area between the curve and the x-axis between 3 and 7 for the graph sine x. And so what that tells us, the interesting thing here is that it's negative, and so we know without even looking at it that there is more area below the x-axis than above. Because we came out with a negative answer, that tells us that we have more negative area than we do positive area, even without seeing the graph. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.